Okay, now that we've looked at the three different rigid transformations, that was translation, reflection, and rotation, let's talk a little bit about our notation. Now, when we talked about translations, we introduced the notation idea. So let's say I asked you to slide a figure 4 units to the right and 3 units down. Then we learned that this is the notation you would write to represent that. So you always start off with the ordered pair xy, and then an arrow, and then you have to look at what's happening. We're going 4 units right, so in the x direction, 4 units to the right, and that's a positive 4 in the x direction. So we're going to add 4 to our x value. And then, in the y direction, 3 units down. So up and down is the y direction. 3 units down would be a negative 3 in the y direction, so we're going to subtract 3. So you just look at the words and decide, is it going to be x plus or minus a number, comma, and then y plus or minus a number. All right, well, that's all we dealt with were translations. Now let's look at reflections. Or, I'll tell you what, let's look at rotations first. And let's start with an example on a graph. I want to rotate something 90 degrees. So let's plot a point. I don't know, how about 3, 5? Let's take the point 3, 5. And we want to rotate this 90 degrees clockwise. So remember, that's going to take us to the next quadrant, that way. That's 90 degrees clockwise. So I know I'm going to wind up down in here somewhere. And so I'm not really worried about negatives and positives in terms of my coordinates. So to get to that point from the origin, I had to go 3 in the x and then 5 in the y. So I'm going to reverse that order, and I'm going to go 5 first and then 3. And I know I'm supposed to wind up somewhere down here. And so that's why I don't worry about the plus and minus that much. I just know what section I'm headed to, and I count 5 and then 3. And so there's my answer. Now what are the coordinates of this point? It would be 5, negative 3. So let's look at the pattern here. What happened with our numbers? The original was 3 and 5, and now it's 5, negative 3. So we switched the order of these two numbers, and then the x number changed signs, but the y number did not change signs. So we switch the order and then take the opposite of the x value. And that's our rule. So we take x and y and we switch the order and we take the opposite of the x value. So for example, this is useful because now we can do this without looking at a graph. So let's say, for example, I started with the point, negative 2, 4. 90 degrees clockwise means I'm going to switch the order of these numbers, 4, negative 2, and then I'm going to change the sign of the x value, so it was negative 2, it becomes positive 2. Now you don't have to write the positive, you could just say 4, 2. I was just demonstrating where that came from. And so that's how you would apply the rule for a 90 degrees clockwise. How about 90 degrees counterclockwise? All right, let's go back to our picture. Let's start with that same point, 3, 5. And now 90 degrees counterclockwise means it's going to be over in this section. And I do it the same idea. I went 3 in the x, and then I went 5 in the y. So I'm going to switch that. I'm going to go 5 in the x, and then 3 in the y, knowing that I have to wind up here. So that's my new point. And what are the coordinates of this new point? Negative 5, 3. What's the pattern with these numbers? Once again, I switched the order. So 3, 5 became 5, 3. And then this time though, I'm going to change the sign of the y value. Instead of changing the sign of the x value, I'm going to change the sign of the y value. So if it was a positive 5, now it becomes a negative 5. If the y number was a negative, then it's going to become a positive. And so there's our rule. And one thing else I wanted to point out is if we made a right triangle from the origin with that point and with our new point, that makes a right angle, a 90-degree angle, and that's what we were doing. We were rotating 90 degrees counterclockwise. So once again, the rule is change the order of the two numbers and then change the sign of the y number. So let's see how that would look in terms of our notation. So we're going to swap x and y, and we're going to change the sign of the y number. So if it was positive, make it negative. If it was negative, make it positive. So look at an example for that. Let's say we took the point, I don't know, 1 comma negative 5. What would that become? Well, we switch the order, so negative 5 comma 1. And then we change the sign of the original y number. That was a negative 5, so we make it a positive 5. All right, so we've done 90 clockwise, 90 counterclockwise. The other one we did was 180 degrees. And notice, you don't even have to say clockwise or counterclockwise, because you could go either way and you'll still wind up at the same point. So let's go back to our original. And this time we want to go 180 degrees. You could think of that as going 90 degrees twice. So you could think of it as going, 90 clockwise, and then another 90 clockwise, so I'm going to wind up in here. Which is also, if you had gone 90 counterclockwise and then another 90 counterclockwise, you'd still wind up in the same spot. So we know we're going to be in the quadrant that's across from, or diagonal from where we started. So if I count, I'm going 3 this way and 5 that way. So what's going to happen is we're going to go the exact opposite, 3 this way and then 5 that way. Here's how I know that my answer is correct. If I draw a straight line connecting these 2 points, it should go through 0, 0, through the origin. And we know a straight line is 180 degrees. So I know that I did it right. All right, so what are the coordinates of this new point? Well, they wind up being -3 comma -5. So let's try and come up with a rule for this one. This time, we did not change the order. That 3 was still in the first spot, the 5 is still in the second spot, but we did change the sign of the numbers. So the +3 became a -3, +5 became a -5. So unlike 90 degrees, we do not switch the order of the numbers, but we do switch the signs of both of them. And that should make sense because if you think of it as 2 90-degree rotations, that means we're going to switch the order once, change one of the signs, then switch the order again, which takes it back to the original, and change the sign of the other one. So when we go over to our rule, this is how we would write it. Any point x comma y is going to become the opposite of x comma the opposite of y. So for example, let's say I had 7 comma -4. And I wanted to rotate that 180 degrees about the origin. So I'm not going to change the order, but I'm going to change the sign on both of them. So x becomes the opposite of x. So it was a 7, it becomes a -7. The y, I make it the opposite of y. So if it was a -4, now it becomes a +4. So the point 7, -4, after it gets rotated, will be -7, +4. So there's your rules for rotation. So now we know how to do a translation and a rotation. And we can just apply the rule without even looking at a graph. That's the nice thing about this. All right, and so then the other one was reflections. What if we reflect a point over the x-axis? And I think these will be easier for you to see than the rotations, because this is pretty straightforward. So let's get rid of this. All right, so let's start with a point. I don't know, why don't we start over in the second quadrant? How about 1, 2, 3, 4. Let's see, 1, 2, 3, 4, 5, 1, 2, 3. How about there? Let's do the point 5, negative 5, comma 3. All right, and let's reflect this. What are we reflecting over? First one, let's reflect over the x-axis. All right, so where's your x-axis? The x-axis is this one. And so where is that point going to go? Well, it was 1, 2, 3 away. So 1, 2. It's going to go right there. Let's erase. I don't want to have the line there. I just want you to see the point. So it's going to wind up being right here. And what are the coordinates of that point? Well, it's still negative 5, but now it's negative 3 instead of positive 3. So notice what happened here. What changed? We did not switch the order of the numbers. The x number stayed exactly the same, but it was the y number that switched. So when you flip it over the x-axis, it's still going the same amount left or right, but it's instead of going up, now it's going down. Or if it was originally down, then it would be going up. And so changing that direction, that's the y direction, that means we're going to change our y numbers. So the x numbers stay the same. The y number, we change the sign. And so that's our rule for flipping over the x-axis. So whatever x was, that stays x, and then the y becomes the opposite. So for an example, let's say we had the point 1, negative 6. What is that going to become? Well, the x number stays the same, so that's 1. And we change the sign of the y number, so instead of negative 6, it becomes positive 6. It's pretty easy to do. If you remember the visual, I think it'll help you. And we have different colors going on here. One more. Okay. How about if we reflect over the y-axis? Let's take that same point, and this time I want to reflect over the y-axis. And remember, that's the one that goes up and down. That's our y-axis. So where's our point going to go? 2, 3, 4, 5, 1, 2, 3, 4. It's going to wind up being across here. What are the coordinates of that? Positive 5, comma 3. So notice when you flip over the y, the x number changes, but the y number stays the same. Because we're still 3 up, we still went 3 up, but this time instead of going left, we went right. And that's the x direction, so we're changing our x number. So that's our rule for reflecting over the y-axis. The y number stays the same, but the x number becomes the opposite. So, just to repeat, look at the pattern here. If you reflect over the x-axis, the x stays the same, and the y changes. To reflect over the y-axis, the y stays the same, and you switch the x numbers. So an example with that, let's say I had, 3 comma negative 4. What's going to happen there? The x number becomes the opposite, so a positive 3 becomes a negative 3. The y number stays the same, so it was negative 4, it stays negative 4. All right, one last one. Let's reflect over the line y equal x. When you do that, you're just going to switch your x's and your y's. Show you a visual for that. Now, if I draw the line y equal x, and if I draw this straight, which I'm not drawing this too straight, but there we go. What I'm going to do is count how far away is it. It's 1, 2, 3, 4 boxes going on the diagonal. So 1, 2, 3. There's my new point. What are the coordinates of this? It's 3, negative 5. Notice what happened. Negative 5, 3 became 3, negative 5. I didn't change the signs of either one. I just switched the order of them. So the x became a y, and the y became the x. But we don't change any signs. And so that's what the rule was showing you. That xy becomes yx. And so those are your rules for reflection. So for example, if I took the point negative 7, 2, and I wanted to reflect that over the y equal x line, we just switch the order to negative 7. Now, you can still do these by drawing a graph if that's easier for you. But these rules make it a little quicker if you don't have a graph available. So let's try some practice problems. Translate the point A, negative 2, 5, 6 units to the left, 4 units up. So this is a translation. And 6 units left, that's the x direction is left or right. 6 to the left means we're subtracting 6 from our x number. 4 units up, that's the y direction, and up is positive, so we're going to add 4 to the y. So our answer, A prime, is going to be negative 2 minus 6 is negative 8. 5 plus 4 is 9. And we didn't even need to draw a graph. Let's look at another one. Rotate the point B 90 degrees clockwise about the origin. So if you want to use a graph, you can use a graph. But if we go back and look at 90 degrees clockwise, that said you switch the order and change the sign of that x number. So let's do that. Let's switch the order. So B prime, 3, negative 4, and then we change the sign of the x number, so that becomes a positive 4. And like I say, you don't need to write the plus. You can just write 4 and be done. And you can verify that using a graph. Okay, how about rotating the point C 90 degrees counterclockwise? All right, so 90 counterclockwise. What was the rule for that? Well, remember we switched the order. And we changed the sign of the y number. So that was a negative 7, that becomes a positive 7. So C prime is 7, negative 6. I'll go back to the rule there for you just to make sure you see that. Counterclockwise, 90 degrees counterclockwise, we switch the order, and then the y becomes the opposite of y. So we change the sign of that. All right, how about the next one? Let's rotate the point D 180 degrees. So remember what happened with 180 degrees. We did not change, get my pencil here, we did not change the order, but we did change the signs of both of them. So 4 becomes a negative 4, and a negative 9 becomes a positive 9. So negative 4, 9 is our answer. All right, let's look at some of the reflection ones. Let's reflect the point E over the x-axis. Remember the rule for the x-axis. When we flip it over the x number stays the same, so it's negative 7, and the y number becomes the opposite. So it'll be -7, -3. Reflect the point F over the y-axis. And it might be helpful, you can refer back to the first page or just write the rule. So the rule, when we reflect, it's right over on the side here. The rule when we reflected over the y-axis was xy. Reflect over the y-axis became the opposite of x, y. So the y number stayed the same. And so it might be helpful to actually write these rules before you go ahead and apply them for each individual problem. Okay, so if I apply this rule, the y number stays the same. So that stays a -5. The x becomes the opposite, so it becomes a +1. So 1, -5. All right, 2 more. How about reflecting the point G over the line y = x? What was the rule for that? xy becomes yx. So we just switch the order of the two numbers. So G prime is going to be 4, -6. And lastly, we didn't talk about this. Reflect the point H, -7, 2 over the line x = -2. So the only rules I gave you for reflection was over the x-axis, the y-axis, or the line y = x. We can come up with a rule for the other part, the other types of lines that we reflect over, but I think it's going to be more confusing than it's worth trying to come up with a rule. So I'm going to take the point -7, 2 and reflect it, let's leave it there, -7, 2, and reflect it over x = -2. So let's plot -7, 2, that's right here. And we're going to reflect over x = -2. Remember, x equals lines go up and down. And so I'm simply going to count how far away is this. 1, 2, 3, 4, 5 away. So 1, 2, 3, 4. There's where my answer is going to be. And that has coordinates 3, 2. So it's probably easier. Some of you might be able to figure out how to do this without looking at a graph. But there's your answer for you. The way I do it without a graph is I say, wait a minute, if I'm going in the x = -2, I look at -7 and how far away is that from -2? That's 5 units to the right. So from -2, if I go 5 more units to the right, that'll take me to 3, and my y number is not going to change. So 3, 2. All right.